SCH4C, Lesson 11, Amounts in Chemistry, Mass, Moles, and Molar Mass. Let's get started. Now, what is 1 mole of potassium sulfate? Well, we want to know what its molar mass is. So we are going to write its atoms, and it has 2 potassium, it has 1 sulfur, and it has 4 oxygen. Now, the molar mass for potassium is 39.10. Sulfur is 32.07. And oxygen is 4 times 16. So we're going to add 78.20 plus 32.07 plus 64. So on our calculator, we get it into the right position. Okay, here we go. Okay, so we want 78.20 plus 32.07 plus 64, and that's equal to 174.27. which can round up to 173 grams. Now, let's look at the next question. What is the molar mass of copper 2 sulfate? CuSO4 5H2O 2. Okay, so what we're going to do is write down our copper sulfate and our 5H2O. Okay, so now we're going to find that copper from our periodic table is 63.56. We know that sulfur is 32.07, and for oxygen is 4 times 16, which is 64. And then we have 5 times H2. Well, H is 1, but we have 2 of them, plus oxygen, which we know is 16. So this is going to be 5 times 2 plus 16 is 18. And now we will do the math. So we will bring up our calculator. And we will have, let's clear it so we're not confused. We have 63.56 plus 32.07 plus 64, and that comes out to 159.63. So here we'll go 159.63. And now we will do our hydrogen and our water. So we know that we have 5 times 2 plus 16 and that comes out to 90. So now we want to add 159.63 and 90 together. So 90 plus 159.63, and that comes out to 249.63. Okay, so there is our answer there, and there is our answer there, and we have finished the first two questions. In question 3, we are asked to find the number of moles of H in 3 moles of copper 2 sulfate pentahydrate. So we're taking a look now for H, and in our formula we see that we have 10 atoms. So we know that 1 mole has 10 atoms of hydrogen. But we're asked for 3 mole. So that's our unknown. Now in a situation like this, we're going to cross multiply. So we're going to say that X is equal to 3 times 10, which is 30. So our answer for this question is 30. Now on to the next question. There are 3.01 times 10 to the 23 atoms present. Now, we don't know whether it's carbon, sodium, or argon, so we're going to say all of the above because it would relate to all of the above. It could be any of them. Okay, the number of carbon atoms present in 0.062 mole of acetic acid is, well, we know from our reading that 1 mole is 6.02 times 10 to the 23 atoms. But we have 0.062 mole from the question, so we're going to have that as our unknown. And now what we'll do is we will cross multiply. So X is going to equal 0.062 times 6.02 times 10 to the 23, and that's going to give us 3.7 times 10 to the 22 mole. But we know that 1 mole has 2 atoms of carbon, and we want them to know how many mole. 3.7 times 10 to the 23 is how many? That's our unknown. Okay, so now we're going to cross multiply. So 2 times 3.7 times 10 to the 23 is 7.4 times 10 to the 23. So, 10 to the 22. So A is our answer. So number 6. The number of molecules of hydrogen peroxide found in 3.15 mole of H2O2 is? Well, we know that 1 mole of H2O2 is 6.02 times 10 to the 23 molecules. Okay, so we have 3.15 mole, and that's our X. So what are we going to do? We're going to cross multiply. 3.15 times 6.02 times 10 to the 23 equals 1.9 times 10 to the 24 molecules. Now, I'm going to let you work on the next page, and we can check our answers, but we're going to move now to part C. Okay, so in this question, what do we know? We know that 1 mole has 6.02 times 10 to the 23 molecules. And we know that we have 5 mole, and we want to know how many molecules. So we're going to cross multiply. So X is 5 times 6.02 times 10 to the 23. This is in mole. This is molecules. Divided by 1 mole. And that's going to equal 3.01 times 10 to the 24 molecules. Okay. Number 2. Now, in this question, we are trying to find the number of carbon atoms in 2.5 mole of methane. So, we know that we have 1 mole is 6.02 times 10 to the 23 molecules. And we know that we have 2.5 mole. So that's going to give us 2.5 mole times 6.02 times 10 to the 23 molecules divided by 1 mole. And that gives us 1.51 mole, molecules, and there is 1 carbon in 1 molecule. This should be 1.5 times 10 to the 24 molecules. My mistake. Okay, so 1 carbon is 1.5 1 times 10 to the 24 atoms. And that is our answer. Okay, number 3. Determine the number of oxygen atoms found in 1.75 mole potassium sulfate. So in this question, the number of oxygen atoms in 1 mole. So 1.75 mole times 6.02 times 10 to the 23rd. Now we're just going to call this formula units for now. Something new. Divided by 1 mole. And that's going to equal 1.05 times 10 to the 24 formula units. Now, there's 4 oxygen in atoms in each formula unit. So there's 4.2 times 10 to the 24 atoms. So we take 4 times the answer we got up here. Okay, number 4, determine the molar mass. So if we are technical, we're going to write the molar mass of mercury sulfide is going to be 1 times 200.6 grams per mole plus 1 times 32.06 grams per mole. This is for the mercury, this is for the sulfur, and that comes out to be 232.66 grams per mole. So the molar mass of HGS is 232.66 grams per mole. Okay. Number 5. Calculate the mass in grams found in 0.805. Okay, little n represents the number of moles, and it has 8.085 mole. And the molar mass from your periodic table is 32.00 grams per mole. And we want to find M, and that is your mass. So we know that's going to be 0.805, the number of moles, times 32.06 grams per 1 mole. So our answer is 25.8 grams. Okay, number 6. In this question, we want to calculate the number of moles found in 168 grams of iron 2 oxide, FeO. So our mass is 168.0, which is given. The molar mass for iron 2 oxide is 1 times 55.85 from the Fe, and 1 times 16 from the oxygen, and that comes to 71.85 grams per mole. Now from there, we want N, which is the number of moles of FeO, and that's going to equal 168.0 grams times 1 mole divided by 71.85 grams, and that comes out to 2.338 mole. Okay, so there are your solutions to lesson 11. As always, email me if you need any more help.